Next up, we have our keynote address, which is by Dr. Inderpal Bhandari, who is in conversation with Dr.Nilay Yajnik. Dr. Bhandari is the IBM Global Chief Data Officer, an expert in transforming data into business value and improved customer experiences by delivering strategic and innovative capabilities that use analytical insights to enable growth and productivity. In 2017, he was named US Chief Data Officer of the Year by the CDO Club and has been featured as an industry expert by eminent publications like the Wall Street Journal and CNN. Dr. Inderpal also was not able to join us live and has very kindly recorded a video with Dr. Nilay. So I will just play that video. Allow me a moment.
So good morning from India, and it's very late in the evening in the United States. Welcome to this conference on artificial intelligence. The theme of this conference is the next decade of AI in business. And it is organized by the Geo Institute, which is an institute set up recently by the Reliance Foundation. We are here to provide some of the best education, the best forms of higher education for the society as a whole. And as a part of this process, we have invited today Dr. Inderpal Bhandari, who is the Global Chief Data Officer of IBM. Dr. Bhandari is speaking to us from New York, where he is currently based. Dr. Bhandari has several decades of experience in the IT industry. He is a graduate from BITS Pilani, my classmate, incidentally, and subsequently he did his master's in computer science from the University of Massachusetts and his PhD in computer science and artificial intelligence from the Carnegie Mellon University. He has nearly 2 decades of experience now with IBM, and he is leading the global data strategy of IBM and ensuring IBM's leadership in the AI space worldwide. Dr. Bhandari is also on the board of directors of Walgreens Boots Alliance. Welcome to this conversation, Dr. Bhandari.
Very nice to be here, Nilay, and very good to see you after all these years. Just one slight correction, if I may. It's the Carnegie Mellon was electrical and computer engineering. It was an AI thesis. And then UMass was also electrical and computer engineering. So just a slight correction there.
Right. But then electrical and computer engineering is the mother of computer science in a way.
Yes,
so
it is.
Right, thank you. So thank you for joining us today. And your PhD was from Carnegie Mellon, and your PhD advisor, one of your PhD advisors was Herbert Simon, the Nobel Prize winner in economics, the Turing Award winner, and also known as the father of AI. And your thesis on engineering AI was probably one of the earliest in the world. So from there, how have you grown in the field? You have seen artificial intelligence growing. You've seen the field of computer science growing. You've seen the field of data science growing. Can you enlighten us about that?
Yeah, so you are right. I mean, I think I was one of the earliest engineering AI thesis. And I did work with Herbert Simon, who obviously was a pioneer in the field of AI and really an intellectual giant of our times. I mean, he'd won some of the highest awards in actually multiple disciplines. So my thesis at that time had to do with, at that time, we were talking about 1980s, 1990. I think my PhD spanned 1985 to 1980. Expert systems were big at that time, so they had these programs that were able to diagnose a certain condition, or they could essentially fix a certain device. and so forth. They relied heavily on rule-based systems. And my thesis was to identify more general models of artificial intelligence. How could you get a program to display more general intelligence like people do, right? So somebody can you could fix a toaster, you can also fix a car, you'll be able to diagnose your child's report card. People exhibit this kind of general intelligence. And so I ended up doing a thesis essentially using the same computer program to diagnose uh, all the different boards that make up a computer. So, the input output board, the CPU board, the memory board, these are very different in terms of their architectures and what they do. So I demonstrated that the same program could actually diagnose all of these different boards. And so it was possible to create a general model for troubleshooting. And what that ended up doing then was IBM Research. They were very interested in my thesis because at that time, IBM, they always had millions of clients and customers. So if a piece of software actually left the production lab and then shipped to millions of clients, and if there were bugs in it, then it became very difficult to address that situation. So they were hoping that by applying my thesis, which was in hardware at that time, but to software now, they could address that problem in process before it actually shipped. So I got into IBM Research. And that problem kind of made me realize that you could look at the data that was coming out of the process of software production, but the model that was being used was actually insufficient to find problems in process. So what I mean by that is typically there is a programming team and then there's a quality control team. And they're different. The quality control people are deciding whether the release is ready, the programmers are producing their software. And I began to realize that the quality control people didn't really have enough knowledge to understand that there could be subtle hidden problems in the software, which would surface later. So I started analyzing the data of the defects in the software, but essentially turning it back to the teams, the engineers, to analyze the data themselves. So that got me into data mining. It got me thinking about how you actually find patterns in data and present it back to people who are non-statisticians. Even though these were engineers and programmers, they were technical, but they were still non-statisticians. They weren't trained in those disciplines. And that was an extremely successful effort, and it backed me into data mining. So you see the intimate relationship between artificial intelligence and data. And then after that was extremely successful, I ended up with, I formulated an even more general problem in my mind. I said, well, if engineers can make use of this, what about lay people? There's a lot of data that's out there. And, potentially everybody could benefit by having a program that was smart and intelligent and could look at the data pertaining to your activity and giving you some guidance and advice. So I created a program called Advanced Scout, which ended up being used by every team in the National Basketball Association in the early 90s.
Right.
And that was a really good example to show, what had the thesis that I had in my mind, that this could be used by the layperson, right? Now, basketball coaches are certainly not technical people. They know their craft, but they don't, and this was Moneyball before Moneyball's time, before the book was written. But it ended up being used by every team. They were using it to understand who to play in playoff games. which was the knockout part of the competition.
Right.
And so even today, you see the progression with sports. It's still the same in that sense that you're using data to analyze and get an advantage with regard to your strategy, to your approach. The difference today is the programs are a lot more sophisticated and a lot more comprehensive. So I'll give you an example. In those days when this computer program, Advanced Scout, used to find a counterintuitive pattern, like it would say, play your two backup players, right? Start your backup players. That's like saying, that's the equivalent of saying, instead of your opening batsman, send in your tailenders to start the innings. So very counterintuitive. So the coach was very hesitant to follow the advice because, he said, well, if this is wrong, not only will I lose the game, but I'll probably lose my career. Everybody will make fun of me. All the newspapers will write articles that are, that don't cast me in a good light. They'll say I don't know anything about basketball. So, why should I do this? So what the program used to do is it used to then take them to the video clips where those players were on the court, and then they could begin to make their judgments as to why that pattern was unfolding. In today's world, these AI programs actually can make use of unstructured data as well. So they can, these programs can actually analyze video, they can analyze scene composition, they can analyze audio, so they can look at the spacing between players, they can make judgments about how quickly players are moving. So it's more and more sophisticated. So a lot of the gaps, a lot of the context that had to be done manually 20 years ago, now these programs are in a place where they can actually apply all those aspects to the analysis of the situation.
Right.
The other key development that's happened is as computers have become more and more powerful, and you have special purpose computers, graphical processing units, GPUs as they're called, they are able to really analyze very, very large amounts of data. And the field has shifted from the more rules-based approaches to the big data and the deep learning kinds of approaches. So it's more a question now, instead of thinking about what rules or representations you had to put in the computer so that these programs could behave smartly. Now it's about showing these programs the data, giving them as much data as possible about the situation, edge use cases, kind of teaching them that way, by example, if you will. The example just being large amounts of data. And these programs are very good at then learning from that, and their performance keeps improving. So that's another aspect that has moved. It's when I was doing my PhD, there was a professor, Jeffrey Hinton, who was also in Carnegie Mellon, but he was far lower down in the totem pole, if you will, because he was somebody who was working on neural networks. And they were not regarded as being that promising. So they just said, oh, we're going to tolerate him because, within academia, you have to have this diversity of thought. But now fast forward 20, 25 years, he just won the Turing Award himself. And it's because it's just become such a phenomenon,
Yes.
the use of neural networks in AI. So the field changes like that.
Right. Yeah. In fact, I remember even in BITS Pilani, you were a very good sportsman, and you were a very good squash player. I still remember that. So I appreciate and I understand, and it's so fascinating to see how the National Basketball Association has used your work to identify their strategies for their players. And one of the findings that you can come out with in this particular model that you've come out with is that the tail ender can be also put in the front. So it's like in cricket, the tail ender people who bat, they may at some point be an opening batsman, and that's a very crazy kind of a strategy to the layman. So isn't it true that sometimes these models churn out things which are totally unexpected?
Yes, completely counterintuitive patterns can come out. And that's why, you have to be able to analyze the context around it so that you're able to convince the decision maker that this is the right thing to do. See, in our view of the world, as IBM and even mine, there is a decision maker that's, actually handling the situation, whether it is the coach, whether it is, the person who's running, say, a supply chain process, or somebody who's responsible for a retail operation. There is a person that's that's actually entrusted with that. And so these AI programs, they have to be able to explain their reasoning to that decision maker. So it's not an approach where it's just that the computer is going to make the decision. In business, there are certain examples where for instance, algorithmic trading, there you can see that you want the program to make the decision because you want the decision made very quickly. But for the most part, in enterprise and business, there are significant decisions that are being made, literally thousands every day. But there is a human in the loop, and they are actually making the final judgment as to whether or not something should happen. So that's the other difference now with these programs. They have to be able to explain the reasoning as to why certain options are being put forward and why they are preferred over others. And they have to be able to do it in a way that the average person can understand. So the explainability of these programs is also a very critical aspect of what needs to happen.
Yes. So moving on from there, from being one of the earliest researchers in the field of AI and data science in the world, you've grown to become the global chief data officer of IBM worldwide. Can you tell us something about this role of the chief data officer?
Yeah, so after IBM research, after working there for 7 years, I went, I quit IBM to start my own company. It was a data mining company. I did that for about 10 years. And I made about every mistake that you could think of, in starting and running a company. But it was like, I view it as my MBA on the street, right? On the street of hard knocks, you learn very quickly. And at the end of that tenure with the company that I founded, I had a very, very good understanding of enterprises and data, because those were my clients and customers. And I was selling to them, I was working with them. And I began to realize that for enterprises, data could be very strategic, but it was not really appreciated at that time by the CEOs and the C-suite. So I came to that realization that for a large enterprise, they were treating data as like exhaust. Okay, we're running our transactions and we're generating some data. Maybe we need something for auditing, but they weren't really looking at it strategically as that it could be a driver of the business. So having realized that, I got an opportunity to create this role of chief data officer at a large healthcare company. There were really only 4 of us at that time. I was the first in healthcare, with that label. But I created that role because I had come to that realization that this is a very strategic aspect of the business that is underappreciated. Nobody knows it. And then, of course, the profession started to grow. And now there are literally thousands of us. And there are, also with the affiliated roles, chief analytics officer, chief transformation officer, chief digital officer. It all has to do with leveraging of data to essentially transform the company and to make strategic decisions and change the course of the company potentially, come up with new products, things like that. During the pandemic, this digital transformation within enterprises has really accelerated, mainly because prior to the pandemic, we were actually, there was awareness, but the CEOs weren't quite convinced yet that they should jump into digital transformation and make those investments and all that. Once the pandemic hit, everybody just understood that they had to go into digital transformation. Their clients were expecting it, their employees were expecting it. There was no other way to do business. And then, so the adoption curve really accelerated within 1 year. I think it kind of, some of the statistics I've seen is like the last 10 years were then encapsulated in that 1 year of progress. And then given that accelerated adoption, the CEOs further learned that you could actually reinvent your whole business. So it wasn't just because now you were digitizing it, and let's say you took customer care and you totally digitized it, that then gave you ideas for brand new products that you could put in front of you. And so there are certain reports that say that in the next 5 years, a lot of CEOs expect over 50% of their business to be different because it's going to these technologies are going to transform it. In the technologies of data, of AI, etc., are going to completely transform and change business. So that's the progression for data, and that's why CDOs are extremely important to help the enterprises actually shepherd their way through to that digital transformation.
Yes, and it's very interesting to see how the role has become a C-level role. You're part of the C-suite now, the chief data officers. So I'd like to know, if you can give us some examples of how data science, as well as artificial intelligence, has been used by companies for competitive advantage.
Yeah, I mean, I think there are some, some areas by now that is broadly recognized that you're going to be able to apply data and AI very effectively there, and there will be significant advantages. And obviously, the earliest movers were, had the biggest competitive advantage. But even by now, everybody knows. Like for instance, areas like customer care, the use of chatbots and voice AI and all the other aspects that come into play there has completely transformed that industry. The same comment with regard to the employee experience within a company, much more digitized, again, very, very advantageous because you can get work done much more rapidly if you're able to essentially connect and enable your employees to collaborate digitally, in addition to the in-person stuff. But if they're able to do that, then you can truly leverage a global workforce very rapidly and very effectively. Financial planning is another one where there's tremendous examples of the use of artificial intelligence to help people make better decisions with regard to financial planning. And, in a sense, it's permeated into almost every major process that enterprises have. When we embarked on our own AI journey, we realized after some time that what AI in an enterprise really meant was you had to infuse AI into every major business process. Like your supply chain process, like your procurement process, your financial processes, accounts receivables, etc. And to the extent that you were able to do that successfully, you would enjoy a competitive advantage. And that's what made the application of AI difficult in enterprises. So the application of AI within enterprise has, in fact, I would say that battle is just starting. It's not over by a long stretch. And in the consumer, that was the AI applications were much earlier and much more clearly understood. thanks to the likes of Amazon and Google and all the auto suggestions being made, the different products being recommended. People had an intuitive sense. But for enterprises, it really has to do with infusing it into every major business process that you have. And to do that, it takes a lot of craft and skill and deliberate. You have to be deliberate in that approach. So we learned all that and shared that with our clients and customers.
Right. So IBM has a very interesting blueprint. It's known as the IBM AI blueprint. So can you tell us something about that?
Yes, so that was I was just going there, right? So in terms of once we understood you had to infuse AI into every major business process. So how do you do that? Well, because you're talking about infusing AI, data is key. So the data has to be fit for purpose. If the quality of the data is not good, if it's not managed, if it's not corrected, curated, all that stuff, your AI is not going to be very effective. In fact, it might give you erroneous results. Since it's AI, we also have technology. That's another major dimension. You literally on these more sophisticated AI approaches like deep learning, you have to literally run hundreds of thousands of experiments very, very quickly. So your technology, both in terms of your special purpose hardware and your CPU units, all that stuff has to work very, very seamlessly and very fast, and the interconnects have to be fast. So there is some very deep engineering and technology work that needs to be done as well. So those are two dimensions that most people get, that yes, if I'm going to apply AI, I need to have these two things in order. But what people generally tend to forget are the other two dimensions that make up our blueprint, right? So there are four dimensions that make it up: the data, the technology. Then, since it involves infusing AI into a business process, the business process is key. You have to transform it. So that's another major aspect of this transformation, that your data, your technology, and then your change as you change the business process, how you go about doing that is also critical. And then, processes are made up of people. There are people running your supply chain process, your retail process. So preparing those people to be able to do this is also key. If they're not educated, if they're not trained, if they're not comfortable with AI, it's not going to work. So those four dimensions have to be kept in lockstep to attain a successful digital transformation. And that's the blueprint. The blueprint is about those four dimensions, speccing that out more, elaborating on that. And then the recognition that you have to march forward in lockstep across those four dimensions. If you go too quickly in one or too slow in another, the whole thing actually slows down, and you can't really you won't be successful.
Right. Now, I remember once you said that, when Alan Turing was asked, will a machine ever replace a human? Alan Turing said, a machine thinks like a machine. A machine doesn't think like a human, which means the aspect of trust, which is so critical to make AI successful in business. Can you give us some thoughts on that?
Yeah, no, so one of the reasons why AI was slower on the uptake in enterprises versus consumers, was the blueprint that I mentioned, where you have to keep these things in lockstep. Another major aspect of why it was much slower on the uptake was on account of trust. And I will explain a little bit more about that. If you're running a large company and somebody comes to you and says, "Oh, this is this wonderful AI system that will help you just become much better at your business," as a senior executive, you'll think twice about it, because you know by now that AI must be infused into your processes, your key processes, right, that run your whole business. And these programs actually learn. So what are they learning? They're actually learning about your process. So they're learning your intellectual property. I mean, that's what it comes down to. So that's the very first aspect of trust. If you don't trust the vendor, of that technology, you're not going to do it. And so, IBM as a matter of principle, once we've recognized all this, is we kind of say, whatever data we run this on, that's yours, it'll stay yours, and whatever insights we draw from it will also be yours. It'll belong to you. It won't really belong to us. So there's trust at that level. Then there's trust at the level of actually being able to explain to the decision maker that what I'm proposing is the right thing to do. That's your counterintuitive pattern we talked about, the tail ender being the opener, etc. You have to explain it. Like if a program tells the doctor you have to amputate the leg, the doctor is not going to do it. The doctor will want to know what else was considered. Why are you making this recommendation? And you have to have that whole reasoning laid out for this doctor in terms that the doctor can understand. So that happens for every decision maker. So there's that explainability aspect of trust also comes into play. Then if you're dealing with data that has to do with people, like if it's, let's say, a large retail operation that's hiring tens of thousands of people, and there's an AI program that's sifting through these resumes and making recommendations, there's an aspect of fairness then that comes in. Because if you're not really being fair to all the candidates, you're actually being biased more towards something or the other, then again, this will not go well, because once it's publicly known that's what's happening, that operation will get shut down. So fairness becomes a key aspect of trust. Right. Similarly, if it's data about people, having their privacy preserved and respected is key. So, many times you're able to, because the tricky part with these programs is, since they discover and infer things, you don't always know what they're going to infer. In fact, you may not even have an idea. You could start with something that looks like it's not very sensitive data, and you might infer something that's very sensitive. So those types of examples, there was a case here in the US where there was a company, a supermarket store that was looking at the consumption of groceries and vitamins and things like that, and it inferred that there was a young lady who was pregnant. So that's a violation of her privacy. When you make that kind of inference, so that also can really rock the boat. So you have to make sure that when you're doing something like AI on data that pertains to people, that their privacy is absolutely preserved and respected, and you're not violating that at all. Otherwise, right. Trust. And the last aspect, I think, of trust has to do with the robustness of these programs, because they can be fooled. These programs, because you train them with data, there are adversarial approaches where if you feed the program data that is designed to actually fool it, then it might do the wrong thing. So you hear these stories about the self-driving car that stops because there's a full moon. It thinks it's a stop sign, but it's actually a full moon. That's because it's been misled, because it's been trained in that fashion. So it's easy to demonstrate that these programs can actually go wrong. They can also go wrong if the underlying data gets stale, if the pipeline of, there are all these transformations that happen on the data, anywhere on that pipeline, if there is some weakness. So you have to kind of establish end-to-end robustness, right, to be able to foster trust in the whole operation. Right? So you have got explainability, you have trust in terms of ownership, who owns the intellectual property, you have essentially trust in terms of fairness and preserving privacy, and then as well as the last point I made here, which has to do with the robustness of the program.
Right. Okay, now apart from several top management professionals who are watching this conversation, there are also many young professionals and many students also watching this. And in fact, the example you gave me of this store, which kind of, the privacy violation happened. It's a case study which I discuss in my class also. A very interesting example. So for these youngsters, young professionals and students who are in our audience today, what advice would you give them, career advice, for a career in AI and data science?
Oh, it's firstly, those are very good choices because these are fields that are very hot. By that I mean they are trending upwards. They're only growing in application, and the professions are growing. So, really is a growth industry. So being there is a good idea. It also is very long lived, right? I mean, I've been doing this for over 20 years now. If you look at the work I did with the NBA, and all those things are still relevant. So it's something that's here to stay for a while as well. So I think first I would say I'll compliment you on your choice. I think those are excellent things to do. I think in terms of the more counterintuitive advice, what I would say is just like we talked about the blueprint, and you had two very hard dimensions with data and technology, and those things are easier to fathom. But then you have the softer aspects here with regard to process and people. Process means become an expert in some domain. If you have some domain expertise, that will hold you in very good stead, as opposed to being a pure generalist as a data scientist. So I think that's one aspect that also could give you an advantage. And then understanding the people aspect of things, the culture and how you change that, and just being much more cognizant of how you work with people, of what the culture is in the place, and adhering to those the values that are there. Those things are, I think, also critically important to be successful. And finally, I would say these are, AI, big data, these are very critical technologies. And what I mean by that is they are going to shape society. So you want to have a hand in shaping society. So, it's very important that we all do get involved. And then, it'll then proceed with the right set of values so that the technology is used for good and betterment, and the aspects that we'd all want it to be used for. So that's the other piece of advice that I would give, that get involved, get deeply involved, and get involved with a set of values and ethics around this so that you can steer it in the right direction.
Right. So I know it's pretty late in the night for you. It would be around 11:30 in the night after a long day's work. So on behalf of Geo Institute, I wish to thank you, Dr. Inderpal Bhandari, for joining us today and enlightening all of us. And whenever you do come to India, please do visit our institute in New Bombay, that's Navi Mumbai. And our students would love to see you in person and interact with you in person.
Thank you, Nilay. Yes, I will certainly take you up on that invitation. Thank you.
Thank you.
I'd like to take this opportunity to thank Mr. Bhandari for such insightful lessons on the application of AI, and how he tried to explain these applications to the layman, and then spoke about the different factors that help in AI adoption, and of course the IBM blueprint. So in and all, I think our keynote address on AI and its application, and I'd like to also thank Dr. Nilay for such insightful questions that helped our audience understand the different domains and facets of AI.